All right, so we push a box to the right with a force of 45 newtons. We want to know the acceleration, we want to know the friction coefficient if the acceleration is 3 meters per second squared. So let's go ahead and draw a free body diagram. So we've got the normal, we've got the weight, we've got the pushing force, and we've got the friction. Now, in the vertical direction, our forces balance, and let's actually calculate what the normal force is based on this balancing. So we've got the normal equals the weight, which is m times g, which is going to be 5 times 10. So we have a normal force of 50 newtons because that's what balances the weight. Now, in the horizontal direction, we know the pushing force has a tug of war with the friction, and the effect is that the mass accelerates. So we're pushing with 45 newtons. We don't know what the friction force is. We do know the box has a mass of 5 kilograms and its acceleration is 3. So we're actually getting that the friction force is equal to 30 newtons. Based on this, let's go ahead and get the coefficient of friction. I know the normal force, I know the friction. I can now use the fun formula. Friction is mu times n, so I have 30 equals mu times 50. And so for mu, I'm getting 0.6. Now I want to know the distance the block goes after being pushed for 2 seconds, assuming its initial velocity was 2 meters per second squared. So we have x equals 1/2 at squared plus v naught t plus x naught. So x equals 1/2. The acceleration is 3 times 2 squared plus 2 times 2 plus 0. And this is going to actually give me 3 times 2 plus 4, which is 10 meters covered. All right. Now for this next set, we're going to look at the graph. So what's the difference between the motion between 0 and 1 seconds and 1 to 2 seconds? Well, let's look. Here we have one slope, and here we have another slope. So what I would say is from 0 to 1 seconds, we move slower than 1 to 2 because slope gets steeper. That would be good enough for me. Describe the motion between 3 and 4 seconds. That's from here to here. So we're moving forwards and then we slow down because we see the slope level off. So move forward and slow down as slope decreases to flat. And then we want to describe the motion between 4 and 5 seconds. We start off slow and then we go backwards, speeding up. So backwards, speeding up. Because it starts flat and gets more steep in the negative direction. And finally, what's happening exactly at 4 seconds? At 4 seconds, we are stopped and turning around. I gave partial credit for saying turning around on the final. So that's it for the and what's happening? So what direction is the object traveling from 2 to 3 seconds? It's actually stopped, not moving, because the position graph is flat. And I need you to say position graph because if a velocity graph is flat, it's still moving, possibly. I mean, it might be moving at a steady speed, but it's still moving. I need you to say that you knew that this is a position graph and that it was flat. That's how it let you know that it was stopped. So that's it for the final exam. I hope these videos were helpful, and I'll also put the PDF solutions online as well.